Hi everyone. We are going to look at some strong correlations today. So we've talked about correlation and that sort of thing over the last couple of weeks when we've talked about height versus arm span data. Last week we finished up our week talking about positive versus negative correlations. These two graphs that we're looking at today, we're going to look at strong versus weak correlation, and specifically we're looking at strong positive correlations in these two examples. So, strong positive correlation. Essentially, we are looking at as close to a model as we possibly can to say it's strong. We can say this particular graph right here with these points, we'd say that this has a very strong correlation, meaning every single one of these points as we're looking at them, they're really, really, really close to forming a straight line. This line is positive, so we could say, if we're talking about this, we could say this has a strong positive correlation, and that strong positive correlation would be a positive 1.0. So a strong positive correlation, we typically put it into the realm of saying we have it goes from a 0 correlation, which is no relationship. Wow, I'm getting better with this online pen. Of course, I say that and then my S is all wonky and my P is all wonky. All right, there we go. Sorry. My zero is no relationship whatsoever, whereas 1, whether it be a positive 1 in these cases or a negative 1, is a super strong relationship. Meaning, if I were to actually talk about the line of best fit that goes through this data, that's maybe not the best line, but if I'm talking about the line of best fit that goes through some data, let's see if I can draw a better one that goes through, ooh, well, of course not. That might not be something I can do. If I'm talking about the line of best fit that goes through some data, if the data stays very close to that line, I can say that I have a strong relationship. If I look over here at this next graph that I see here, I have also a very strong relationship because I could create a line of best fit that works for this data, but I'd say it's less strong than this one. This is a very strong relationship. I would say this is a strong relationship. If I were to put these dots in a calculator, depending on how far off they are from the line, I might get what's called a correlation coefficient of maybe plus 0.9, okay? Just a little bit less than 1. The closer I get to 0, the closer I get to no relationship. So I would expect a 0.3 relationship to look something like this, with dots very scattered about, there being some sort of random reason to it, but having a decent spread in the data. Wow, that was really bad. A decent spread in the data that essentially causes me to not be incredibly confident about making solid predictions. You might also see in data like this having a few major outliers or points that just do not fit with the line, and you might see those a whole lot more often when you see something with a less strong relationship. So we are going to watch one more video after this to talk about weak relationships to really get that through our brains. And then we're going to look at the whole continuum of what the different relationships can look like in terms of correlation coefficients. Thank you for watching this video. Be sure to watch the next one so that way you can understand weak correlations. Thank you.